So, generation of the laser, all these things, that is the physics of the laser, that can be explained or in the different module, but knowing all this fact about the laser, we can say that in this case the laser beam welding is mainly advantageous to produce the high depth of penetration, and it can create the limited size of the heat affected zone and limited size of the molten pool. That means, aspect ratio between the width and the depth of penetration is relatively more in case of laser welding process as compared to the other arc welding processes. Other point of laser welding process that it can be used either conduction mode or keyhole mode welding process, both depending upon the requirement. So, conduction mode welding process means relatively the aspect ratio, that means width and depth of penetration is relatively low as compared to the keyhole mode welding process. So, conduction mode welding process we can get the not much depth of penetration, but high amount of the weld width, but just vice versa in the characteristics of the typical keyhole mode laser welding process, where high depth of penetration and very small amount of the weld depth is produced the keyhole mode welding process. So, depending upon the application, both conduction and keyhole mode laser welding process can also be used. In this, of course, like other arc welding processes, here also the laser beam welding also use the shielding gas to protect the molten pool of the material. But if we look in the typical advantages of all this process, that first is that very narrow weld zone can be obtained using this laser beam welding process, because it is focused on the very small zone, but at the same time the intensity is very high as compared to the arc welding processes. Relatively high quality weld zone can be produced by simply making the usable of the keyhole mode laser welding process. In this case, very small heat affected zone, dissimilar combination of the materials can be welded using the laser welding processes more easily as compared to the arc welding process. And of course, laser welding process is one of the most suitable welding process specifically to design and development of different micro and nano welding process, because laser source can be controlled very precisely. So, taking this advantage, there are the several developments of the micro and nanoscale welding process has been done, where other arc welding process may not be suitable for the micro welding processes. Of course, since we can use the shielding gas also, there is no need of the vacuum in this case like electron beam welding processes, and it can produce the low distortion of the workpiece, since heat is focused on the or in this very narrow zone. That way it can produce the relatively low distortion as other arc welding processes. But if we try to look into certain limitation of this welding process, the one limitation is that the cost of the equipment is very high and as compared to the any other arc welding processes. And of course, it is not completely free from the contamination of the outside atmosphere. Therefore, there is a requirement of the shielding gas even in laser welding processes. So, these are the two limitations of welding processes, and maybe we will try to discuss more about on this laser beam welding processes later on. And next we can look into that another high beam energy welding process, that is called the electron beam welding process. So, in this case, so it creates there is a high beam of the flow of the electrons, and this process definitely it carried out under the vacuum, so that the flow of the beam cannot be affected by the atmosphere, and definitely it also follow the keyhole in this, and that means even the high depth of penetration welding process can be achieved in using the laser beam electron beam welding process as compared to the laser beam welding process. So, if we very precisely look into the different advantages, that deep penetration weld can be produced, and even narrower zone and heat affected zone or narrow weld can be produced as compared to the laser welding process. Very small distortion is the another advantage of this process. Filler material is not required, and another advantage is that electron beam welding process, that the lot of combination of the dissimilar materials can be welded more easily as compared to the other welding processes. But of course, having some disadvantage in this case, it is even more expensive equipment than laser welding process, and very high production cost is also very high. That means, when precision is the main requirement of any kind of welding process, then it is better option. That means, electron beam welding can be used as compared to the other welding processes, but another during the electron beam welding process, the secondary scattering, that means X-ray irradiation also happens during the process. So, that needs to protect during the welding process. So, apart from this disadvantage, in general the electron beam welding is normally preferred when there is a requirement of the high precision. It is by compromising the cost of this welding process. Now, other welding processes, we can see that the other type of welding process, that is called the thermite welding process, where the chemical source can be used as a source of the heat. So, basically the generation of heat is mainly controlled by the exothermic chemical reaction between the components of the thermite. Thermite can be defined as a mixture of the metal oxides and aluminum powder. We can look into the example. For example, if you look into this equation, that aluminum and Fe3O4, they react and forms the more Fe, that means pure iron, and that aluminum oxide, that produces the oxide. So, during this reaction it also creates the heat. So, that heat generated is responsible to weld the two different materials, but at the same time that pure iron here becomes the part of the final weld joint. So, therefore, the molten metal produced by the reactions acts as a basically ferrule material joining the workpiece after solidification, and that reaction, since reaction produces the aluminum oxides and free elemental iron and large amount of the heat, and that exothermic reaction occurs is basically reduction and oxidation. So, here aluminum oxide is much less dense. So, that can be separated out from the molten zone, but it is also possible to improve the welding process by sometimes by adding some kind of the other aluminum elements, since the production of the pure iron becomes the final part of the weld joint. So, when you try to join the steel, so that using some adding components can improve the composition of the steel along with the molten pure iron. So, if we look into other type of reaction also in thermite welding, that chemical reaction, other metal oxides can also be used here to produce the copper. Here also second equation we can see that there is a production of the copper. So, copper or copper based alloy can also be welded using the similar principle. Now, if you look into that advantage of this thermite welding process, we can see that heat of the chemical reaction is basically utilized in this process. Therefore, no need of the extra power source is required, and specifically these large heavy sections can be joined in this process. So, typical application we can see the thermite welding in railway track, the joining of the component using this process. But of course, having the disadvantage that one pointed out that only ferrous, maybe steel, aluminum, nickel materials can be welded, and that means you need to choose the material so that the reaction may happens in such a way that produce the amount of the heat generated can produce the metal, but at the same time the production of the pure iron from the equation we have seen, that becomes a part of the actual welded joint. So, that is why it is having limit combination of the material and the thermite. Relatively slow welding rate. So, the welding rate is not as much as high as compared to the other arc welding processes, but high temperature passes may cause the distortion, and that actually affect the grain structure in the weld zone. Sometimes the weld metals may contain the hydrogen, and also the slag inclusions or contamination is the another difficulties, maybe disadvantage of this welding process. So, in summary of all these welding processes, we can see the few points that is most important points from overall idea of all the different types of the welding process and their basic structure. First is that heat generation is basically in the electrode that actually depends on the polarity. So, amount of the heat generated on the workpiece or on the electrode, that depends on the whether we are using the direct current electrode positive or whether we are using the direct current electrode negative. So, when you use the direct current electrode negative, in that case the maximum amount of the heat generated in the workpiece material. So, welding of the highly oxidized material, that means having aluminum oxides. So, where the cleaning action of is most important, in that case AC current, that means alternating current, is more preferable. Third point is that thermal conductivity of the material is very important parameter, and that thermal conductivity actually decides, that is the most influencing properties of the material, that actually influence the amount of the fusion zone as well as the more on the what is the amount of the or size of the heat affected zone. So, this dimension of this two heat affected zone fusion zone is mainly depends apart from the other parameters. The main parameter is the thermal conductivity of this specific material. Now, when we discuss about the type or nature of the power source is required for different welding process, in general we can say the flat characteristic of voltage and ampere current curve is suitable for the semi automatic arc welding processes, but on other way the sharp drop characteristics type of the power source is more suitable for the manual arc welding process. So, if we look into the what is the nature of the shielding gas, the inner type of gas is the most preferable choice for the shielding gas. And next is that in plasma arc welding process, the non transport arc is specifically is suitable for the thermal spraying or the in the coating purpose rather than the welding processes, welding of the different materials. And laser beam welding or electron beam welding is mostly preferred when there is a requirement of the high depth of penetration and the minimum heat affected zone and the minimum fusion zone. Definitely this laser beam welding and electron beam welding, they produce the high depth of penetration through the keyhole mode, formation of the keyhole mode welding processes. So, thank you very much for your kind attention. Next we will try to the next part of the this module.